Hey guys, welcome back. Okay, so what we have done in the first part of the video was take the turbocharger, show you the stock unit, disassemble, inspect all the intricacies inside. We showed you how we look at the various components, the bearings, the VNT assembly, the compressor wheel, the shaft, split seal ring, whether or not there's carbon build-up before and after the split seal ring, and the air oil separator, etc, etc. And we went and took the compressor housing, loaded it onto the CNC machine, clocked it up, set up the datum, loaded the program, CNC profiled the entire thing up until a stage where everything was done and ready for assembly. Obviously it had to be cleaned first. What we're doing in this video is now carrying on from what we did in part 1. And we're going to basically carry on and show you the assembly after all the components have been cleaned, how they look after they've been cleaned, and no, they haven't been media blasted. So not the correct way to clean any turbocharger, whether you're reconditioning it, upgrading it, or whatever the case is. If you strip a turbocharger and you need to clean it, media blasting is not how it's done. The OE factories do not do it that way. We do not do it that way. Many people do it that way. Be that as it may. So let's go into the actual exciting bits and pieces. You'll see everything laid out on the table. We'll show you all the components that we're going to be replacing, how we assemble everything. Once assembled, we'll put onto the VSR machine, we'll balance that unit, we'll reassemble and set orientation, we'll test the actuator, and then we'll basically put the unit onto the flow bench, and we will set up the midpoint and maximum flow settings while the rotating assembly is turning. Many people claim to have flow benches and they have a little finger that sits inside and holds the rotating assembly still while they measure flow through a turbine. No altitude, no airspeed, no idea. And that is a saying that comes from the aviation industry. Unfortunately, a turbine is a rotating component, and in order to measure flow through a turbine, it needs to rotate. So if you ever have a question, or if ever somebody offers you some form of flow calibration and their flow bench does not rotate the rotating assembly in order to measure flow through the turbine, I'm afraid you're not going to get an accurate result. But be that as it may, after the flow bench, we will then, after we've set up the VNT assembly on the flow bench, we will do what we term a dyno graph. We test the performance of the turbocharger based on the design aspect of the billet compressor. We know more or less what it should flow, and on your x-axis you'll get on RPM, and on the y-axis you'll get a flow reading, and in the actual graph you should see a nice linear curve, and we'll share that information with you guys as well. I hope you guys like this one. This is going to be the second of 3 parts. The last one will be when we take the vehicle and put it onto the rollers and start doing a bit of tuning to extract the power. We are in lockdown at the moment, so it might take a couple of weeks before we're able to even get that done. But that's going to be part 3. Let's get into part 2. Hope you guys enjoy this one. Catch you next time. Okay guys, we're back in the workshop. What I'm going to do now is test the actuator. This is a vacuum actuator. Most of you guys are obviously aware of actuators that require pressure in order to actuate the arm or to allow the arm to move axially. This requires vacuum for the arm to move. So what we're going to do is we're going to apply a pressure to verify that the diaphragm is intact and doesn't have any holes and it's not leaking. So for that we're going to basically go into calibration, pneumatic vacuum, and then what we're going to do is we're going to apply a preset vacuum to the actual head unit of the actuator, and we're going to leave it there and verify what the actual versus the preset is. So I'm just going to drag that up. You can see that the rod will move. I'll do this a few times. We're sitting at 0.29 of a bar in vacuum. That's why it's got a minus. That's the preset and the actual. So you'll see that they will remain as close as damn to one another, which verifies that the diaphragm inside of this head unit is in actual fact intact. I can play around with this just to try and force a leak if there is, and everything returns back to normal again. So I'm happy with that. Watch as I slide this down. Keep your eye on the rod. You'll see the rod will move, and you can hear and see that there's no more vacuum. Watch the rod as I drag the slider. The rod will move. I'm at minus 0.42 preset and actual minus 0.42. So I'm happy that this actuator is in fact intact and the diaphragm is not damaged. So this is a test, a pass test. As we're back in the workshop again, and what we've basically done is laid out everything on the table after the cleaning process and obviously the CNC machining, which you guys witnessed yesterday or in part 1 of the compressor housing. Everything's been cleaned. We've tested the actuator and it's now time to assemble. Now this is the brand new components which we're going to be replacing. As I mentioned yesterday, there's the new O-ring, there is the thrust bearing, thrust collar, split seal ring for the thrust collar, ring for the turbine shaft. This is the washer and spacer together as one piece, brand new nut and bolts, journal bearing, etc. There's the O-ring that fits inside the bearing housing. Bearing housing has been cleaned. There are a few tricks as to how to clean these, which we're not going to share over here. But this bearing housing has been cleaned inside of specifications. Turbine shaft has also undergone a chemical clean. It's a non-caustic chemical bath. And backplate has also been CNC machined, as you can see. Guide ring and all of the VNT components have been cleaned. The heat shield has been cleaned as well. And there's our billet compressor. This is the old compressor wheel with the oxidization on the top of the blades. This is the one that came out, the stock compressor wheel. And if you look at the bottom of the blade, look at the color at the top of the blades, look at the color of the bottom of the blades, you'll see it looks like it's been sandblasted. So it's not that bad because the blasting doesn't extend all the way to the root of the compressor wheel, but you can see it is a used wheel. And it tells you that there have not been large particles that have come through because the leading edge of the blades are not damaged. We went over that yesterday. So we'll put that one side and we're going to do a fast forward on the assembly of this bearing housing and core assembly, and then we're going to move over to the VSR machine.
Friday's disappointment is Sunday's empty tomb. Since when has impossible ever stopped you? This is the sound of dry bones rattling. This is the praise make a dead man walk again. Open the grave, I'm coming out. I'm gonna live again. This is the sound of dry bones rattling. Yeah. Pentecostal fire, stirring something new. You're not gonna run out of miracles anytime soon. Yeah, resurrection power, rising my face too. Yeah, I believe there's another miracle here in this road. This is the sound of dry bones rattling. This is the praise make a dead man walk again. Open the grave, I'm coming out. I'm gonna live again.
Okay guys, at the balancing machine, we've put the oil drain and the oil feed fitting on. This is the rotating assembly we've just built. We're going to put this into the actual pedestal now. First have to take this out. Just want to get a pair of pliers to pull that pin out. Keep holding there. Oh yeah. Okay, pins out. Just load it into the pedestal. Going to connect the oil feed line, and we are ready to do a balance. What we're going to do now is we're going to give it a reference. Any blade, choose a blade, and that's going to be our reference to 12 o'clock. We're going to magnetize the shaft nut. We've already set up the sensor. Lock that down and bring our piece forward. Always like to just take something just to make sure that the blade turns inside there and is not making contact with the protective sleeve, and we're good. So what we're going to do is we are going to V8 cruiser. We always start off at around 40,000 RPM. We just take it easy. Press start, new. Okay, so it's 0.26 of a gram per millimeter squared, which is literally nothing. Let's go up to 60,000. Start. Okay, so we inside of the tolerance. There's our tolerance over there. We're well within inside the tolerance. Let's get about 80,000 RPM. Start. The reason it sounds rough is because the shield does not cover the entire compressor wheel, as you can see here. As the wheel slows down, the reason for that is the wheel is larger than what the inside diameter of the sleeve is. So that's the reason it sounds rough, but obviously you can clearly see that it's not. The bearing system is intact because this curve is nice and smooth. It's not jittery and jaggery. It's starting to come down at 80,000. So let's take it up to about 100. The balance spec on this specific turbo is 105,000. We'll go up to about 120, maybe 130, because we're going to be running quite a high boost. We're inside balance. No need to take a cut. I just want to go up to about 110, see what she does. That's sitting at about, she's far away from the tolerance, so we can risk it a 120, but let's rather be safe than sorry. Over here you'll see 4-bar oil pressure. Okay, that's the result there. We're still good at 110,000. I just want to verify 120, and we will be on our way. 120,000 RPM. We are well inside of the balance tolerance. We did not have to cut anything on the nut. So that tells you that the bearing system is intact. It's great. It tells you that the individual components, like the compressor and the turbine, are balanced individually, and they're balanced 100% as well. So that is a 100% success in terms of a VSR balance. This is ready to be installed into the housings, and off we go. What I want to show you something quickly is really interesting. Have a look at how little drag there is on this compressor wheel as I spin it, okay? How it slows down. It doesn't come to an abrupt stop. It slows down and comes to a stop. Now I'm going to do the same thing while I pump air through here. Now I'm going to just clear all the oil galleries by pumping 8 bar of air pressure through this oil feed line, so that I can just get everything out. So when we take the core off, it doesn't leak oil all over the place. And while I'm busy pumping air, I'm going to spin the wheel. Have a look at how quickly it stops. That'll give you an idea of how much drag exists when air and or oil is flowing through the bearing system. Now before I do that, I want to just put a rubber piece over there so that we don't spray oil all over the place. Just give me a second. Trying to put a tube on here so that we don't land up with oil all over. And right, I'm gonna press that button for me and hold it in. Rich, press it, hold it. Okay, now we're busy pumping air through there. See how quickly the wheel stops. It comes to an abrupt stop. Keep pumping, keep pumping. Okay, stop pumping. Can you see the difference? So I'm happy with that. Something interesting. There's all the oil out. Oil feed can come off. We can remove the rotating assembly, take the oil feed fitting and the return fittings off, and we can then install them back into their end housings, set the orientation, and we'll be moving over to the flow bench after that. Okay guys, so we're back here now. Right, what we're going to do is I'm going to assemble everything, put the rotating assembly back into the turbine housing, obviously locate the VNT, set that up, put the compressor housing back onto the rotating assembly, actuator, bolt everything down, set the orientation, put the little pin in, put the little studs in for the water in and out, and get the turbocharger assembled, ready for the flow bench.
Saturday was silent, surely it was through. But since when has impossible ever stopped you? Friday's disappointment is Sunday's empty tomb. Since when has impossible ever stopped you? This is the sound of dry bones rattling. This is the praise, make a dead man walk again. Open the grave, I'm coming out. I'm gonna live again. This is the sound of dry bones rattling.
Okay, so we have this turbocharger now set up on the flow bench. We've got everything connected, we've got a speed sensor connected, we've got the flow through the turbine and the flow through the compressor. We have some of the maps that we've gone and created ourselves, including that specific guy over there. So when we open it up, the calibration data will actually appear on the screen. This specific data is a secret, it's not something we share, so we will not be showing you that. However, what we will be showing you will be this here, which is a performance graph, something like a dyno graph on the turbocharger, which will basically give us turbine pressure, actuator pressure, RPM, a couple other things, and then obviously your RPM across the x-axis and flow on your y-axis, and it'll actually plot a graph so we can actually see what sort of airflow this turbocharger actually provides. And then this can be plotted together on a gas burner to create a compressor map, which is something we also do for the billet wheels that we design, something no one else in this country is able to do or even has the knowledge to do. So we're very proud of that fact. But we're ready to go, and we're going to just get into the calibration here, and we're going to hit start. You will see that we also have the temperature and the oil pressure. There the turbocharger runs. We are actually doing a measurement at the moment, which this one I don't mind showing you. It's the others that you will not be able to see. There's your RPM over there, and once it's ready and finished, the turbocharger will slow and come to a stop, and we will carry on with the other settings. That was max. We're going to go to mid-flow and min-flow next. The charger is now being set up in the BMT. We're more than happy with it. We're now doing a flow test. So we'll have RPM across the x-axis and flow across the y-axis. We're going to be measuring compressor flow, turbine pressure ratio, and a couple of other things there as well. We do this in a 3-step actuator position, and we monitor for cavitation, airflow, and a few other things just to verify that we're happy with the final result. No irregularities in the graph, there's no jaggers in the graph. We are very happy with the results so far, and we will run this up to a certain speed, and we'll give this a pass. Grass is smooth, very happy. So that's pretty much the assembly, the flow calibration, balancing. That's a hybrid upgrade. That's how we do it here at Turbodirect. We're a little bit different to where the other guys and how the other guys do it. We have our ways, other guys have their ways, but I hope you guys have enjoyed that. The next step from here is to obviously take this turbocharger, which is now completely assembled. It's come off the flow bench, it's ready for installation, install onto the car, and get onto the rollers, do some tuning, and that's obviously going to be the third and final part to this 3-part series. But as I said, because of the lockdown, we don't know when we're going to have time to be able to do that. But click on the bell, subscribe, like, comment. You will be notified as soon as that does happen. Hope you guys like that one. We'll be doing a couple more on a few other big projects that we've been busy with. So it's quite exciting stuff coming up. Hope you guys enjoyed it. Once again, cheers. See you next time.